Hello everyone, my name is Aditya Shankar and today I prepared this video to explain a very important concept in operating systems, that is interrupts and its types. So let's begin. First of all, let's see what we will be covering in this video. So we will be covering what are interrupts, its types that are hardware, software, exceptions, interprocessor and non-masterable interrupts. And then we will be discussing the interrupt handling process, that how interrupts are handled by the operating system, and we'll be ending with a conclusion. Okay. So first of all, what are interrupts? So an interrupt is a signal generated by hardware or software to disrupt the current flow of execution of a program and transfer control to a specific routine called an interrupt handler. So a lot of big words, but basically in simple language, like we are doing something and a family member call that please do something for me, fetch a glass of water. So what is happening? You are interrupted, right? So that is only the basic concept of interrupt in operating system too. Like whatever the program is being executed currently, if some exception comes or some error comes or some request comes, then the operating system has to check that, and that is an interrupt. What are interrupts needed for? Interrupts help in handling time-sensitive events and responding to external devices and improving system efficiency. So basically, the most important feature of interrupts is that it makes the operating system responsive. If the operating system is doing something, we want it to do something else, and we have to wait till the first task is executed, it is very time consuming, and it is the basic principle of our machines are that we need to maximize the utilization of CPU. So that is hindered over here. So interrupts are needed because they make it responsive. Whenever an interrupt occurs, then the operating system has to check to it and see whether about priority and all. Let's discuss it further. So types of interrupt, as I mentioned, these are the types of interrupt. We'll be covering it in this video. First of all comes hardware interrupt. So it is easy to understand hardware interrupts that are generated by the external hardware to request the attention of the CPU. Basic understanding. Whatever the interrupts are generated by the hardware, they are covered in the hardware interrupt. So these allow the processor to respond promptly to events and perform necessary operations. For example, keyboard input, any kind of input, and timer events. For example, every 10 seconds we have to do we need something to be done by the processor. So there that will be included in timer events. Why are they needed? They enable the system to respond to external events of the hardware and perform tasks based on time-based requirements. Okay. The key aspects that are needed to be covered in the hardware interrupt. First of all is triggering events. How, on which cases the hardware interrupts are triggered. So they can be timer interrupts, as I told about timers. Every 10 seconds we want to do something. Input output interrupts. If we are inputting something while an execution is going on, an interrupt is raised, and hardware failures. Whenever we want something to be happen, but the hardware is not capable to do it, then hardware interrupts are generated. Now, interrupt controller. Some of these points will be covered in every type, like triggering events, interrupt controller, interrupt vector, interrupt routine, interrupt service routine, and all. So let's get a general idea. Interrupt controller. It is the system that receives the interrupt signals and prioritizes them and forwards them to the processor. Like basically, and let's see. In the interrupt vector, after the prioritization of the interrupts, these based on the priority, the interrupts are given and the number and on the types too. So that is contained in an array or a vector called the interrupt vector. Next up, as I mentioned, interrupt service routine. So this is the most important feature. This is the place where all the interrupts are basically organized and handled. So it is a it is a program that is helped to handle the interrupt. Interrupt priority. As I mentioned, according to the basic understanding that how much the priority of the interrupt is, and that way it is ordered. So there is nothing there. Next up is software interrupts. Again, basic software, the interrupts that are raised by software or exceptional conditions within a program. to request specific services from the operating system. For example, system calls, software exceptions, debug breakpoints, etc. If there is prioritizing, like all that. Why are they needed? They enable programs to perform privileged operations. Now, privileged operations is when the OS needs to switch from user mode to kernel mode. We'll be discussing it. And then it to request services and handle exceptional conditions in a controlled manner. Key aspects of software interrupts. The triggering events that cause software interrupts are system calls and exceptional conditions. Okay. About the vector, it contains the addresses of the interrupt handler routines and to corresponding to each software interrupt. Interrupt service routine. Whenever software interrupt occurs, the ISR performs the necessary operations and system calls required by the software interrupt. Privilege execution. As I said, what is privilege execution? So it is basically when the operating system needs to convert from user mode to kernel mode. Kernel mode is nearer to the computer hardware. So some programs may require some internal basically performing of the hardware. So then we have to switch from user mode to kernel mode. So that is an interrupt in the software interrupt. They are beneficiary as they allow for modular programming as for different interrupts. There will be different interrupts for different conditions. So that makes the program modular. Next type, exception. Exceptions are like of course, like there's a famous divide by zero error. Like if some number is being divided by zero, so we know that it's indeterminate. So that is an exception, and hence an exception interrupt is generated. As you can see, generated by the CPU when an error or exceptional condition occurs during the execution of an operation. Why are they needed in handling error conditions and exceptional situations? Let's see. Okay, under this is first nested exception. So what happens that if there is an interrupt already that is being handled by the operating system, and in the same time next interrupt is generated. So right now the operating system, or sorry, the microprocessor is already performing one interrupt, and in that time another interrupt is generated. So what happens that this is nesting of interrupt, which is not a right case. So in this case, we need to prioritize the interrupt. What is interrupt latency? Latency is a common word for us now. Like whenever if it takes a lot of time to solve or handle one interrupt, in the meantime another interrupt occurs, that latency should not happen. So minimizing it is a important word. Next up, priority inversion. So if a low priority interrupt is being handled and at the same time a high priority interrupt comes. So this will require priority inversion so that the high priority interrupt is handled first. Okay. Interprocessor interrupts. These are the next types of interrupts. Whenever there is a multiprocessor system, so when one processor generates an interrupt to stop the execution of the another processor, this is interprocessor interrupt. Why are they? Okay, first examples. This then facilitates the communication between processors and the synchronization unit. Why are they needed? They enable coordination and communication between multiple processors. Okay. There are types of interprocessor interrupts. These are again just simple things. Software generated interrupts when a software of one when the software that is being executed in one processor interrupts the execution in another. That is software generated interrupts. And similarly in hardware generated whenever the hardware interrupt is generated in one processor to stop the execution of another processor, that comes in hardware generated interrupt. Okay. Usage scenario. So in these cases, interrupts are needed. So task distribution is an important case that is handled by interprocessor interrupts. Also, synchronization of events, resources, basically between the different processors of the multiprocessor system, and global operations. Global operations are when there is a shared resource and the different processors are operating on that shared resource. So there needs to be coordination between them. So that is basically covered in the. For this, next up point is coordination mechanism. That is, of course, synchronization that is used to coordinate access to shared resources and ensure the orderly execution of parallel tasks. Okay. Next is non-maskable interrupt. So the background of non-maskable interrupt is basically hardware interrupts have two types, maskable and non-maskable interrupts. Maskable interrupts are those interrupts which can be stopped by a software or basically that can be disabled, and non-maskable interrupts are the hardware interrupts that cannot be disabled or ignored by conventional means, that is by any software or something. So what are the examples? The critical system errors and hardware failures are included in this. So basically, if there is a system error or a hardware failure, that is a basically necessary condition that needs very quick attention of the processor to resolve. So these are non-maskable that you cannot stop these interrupts. These are very crucial for the process. They are, as I said, used for critical error handling and require immediate attention. The aspects, triggering events, hardware failures, and system effects, again, the critical conditions that need to be handled very quickly. Priority and handling. The non-maskable interrupts have the highest priority since they are again critical. Basically, this is the uh, thing that what we need to know is that there is the critical conditions which need quick attention. So that is basically covered in NMI. Okay, non-disabling nature. They cannot be they are not disabled because they need to prevent software or low priority interrupts from interfering in the NMI handling process. Okay, interrupt handling process. Now let's see how the interrupts are handled by the processor. So there are some necessary steps included in this. So first is interrupt detection. So there is an interrupt request line. This is the hardware which the processor interprets every in some time after every execution of process, for example. So if an interrupt is raised, so the interrupt request line cancels. Next is interrupt acknowledgement. So when the CPU catches the interrupt, it checks where there is an interrupt and it dispatches it to the interrupt handler. Okay, in between what happens is context saving. So before the interrupt is handled, the operation that was there in being executed, that its context needs to be saved, like its program counter, that is the location of the instruction. The register values and other relevant information needs to be saved because an interrupt is being handled. Okay, interrupt vectoring, like I told, interrupt vector that keeps the information about the type and source of the interrupt by using a vector or an array. That is it. Then is the interrupt handling. In the interrupt handling, the processor transfers the control to the appropriate interrupt handler routine, that is ISR that we discussed, based on the interrupt vector. That is the type and the indexing the priority. Interrupt servicing. During servicing, the interrupt handler routine executes the required operations or services required by the interrupt. So basically, manages the interrupt, ends the interrupt, whatever way we can understand. Interrupt completion. Once the interrupt servicing is complete, the interrupt handler routine is signal signals the end of interrupt handling process. That interrupt has been handled, and now the program can go back to its execution. So what happens? Context restoration needs to be done. That is the saved execution context, that was the program counter and register values. These need to be given to resume the interrupted task that was being performed. And then return to normal execution after the interrupt is done. As we said, context restoration, then the processing of the back to the execution of the previous program that was being handled. Okay. In the end, interrupts are essential for efficient and responsive operating systems. As I told, operating systems need to respond to the required operation. Otherwise, there is no use basically. No, that there is not maximum utilization of the CPU. Then what is the need of machines? Different types of interrupts cater to specific needs. For different interrupts, there are different types like hardware, software, error handling, interprocessor communication. And at the end, understanding interrupt types and their handling process is crucial for developing reliable and efficient systems so that we can increase efficiency and maximum utilization can be obtained. Thank you.